All right, here we go. We're going to finish up 12.2. And it's using the same stuff that we've done before, that trig ratio stuff. But we're going to do it in a practical situation. You know, people say, well, why do we use this? Why do we use this? I hear that all the time when I'm a math teacher. I actually went, anybody listening to me? Eyes up here. I've started. Thank you. So, you good? Braden?
What?
You good? Didn't you do the long moan right there? All right, everybody listen now. For the last 10 or 11 years or so, I've just done media arts, haven't taught any math. So I went 10 years in a row without anybody asking, when am I ever going to use this? But for 25 years before that, when I was teaching math, almost, not every day, but a lot of times people would ask, why do we use this? Why do we use this? Sometimes there's good reasons that I could give you why people use this stuff. There are times in algebra and geometry and different things like that, calculus, pre-calculus, where I honestly couldn't tell you. All right, a lot of math teachers try to say, oh, you're going to use this all the time and da 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 da. Yeah, there's a lot of stuff that you learn in high school that you're not going to learn you're not going to use, I should say, the rest of your life. Anybody paying attention? I got like 0 eyeballs at me. Come on. Okay. But this stuff right here is absolutely something you can use. My dad actually told me,
I'm not the only one talking.
it doesn't matter if you're the only one, but you are one that's talking. It doesn't matter that you're the only one. I don't understand why that's a good excuse. I just never understood that. I'm not the only one. It doesn't matter. You're on I-95, flying down the road. Listen. Let's just do an example. I'm tired of this. All right. I took a picture of the example in the book. Put it on here. Let me move it just a little bit. All right. It fits right in there. So this is right from the book. And this is what it says. I'm just going to teach it to you since nobody's paying attention. It says a survey team flying at an altitude of 7,000 feet. So they drew a picture right here. Okay, they're not always going to have a picture. On the test, I might have a couple of these problems on here like this. Okay, we can call them word problems or story problems or whatever you used to call them when you were a kid. But this is practical application for what we are learning in here. Okay, with this trig stuff. It says they're flying, so supposedly they're in a plane, I guess, if they're flying, at an altitude of 7,000 feet. So you draw a little plane. You don't even have to draw a plane, just a little dot or something just to indicate where this person is. They're 7,000 feet above sea level. So this level right here, this would be sea level, and there's your 7,000 feet. So pretty easy so far. Now, here's the thing that we're going to learn today, okay? Angle of elevation and depression. We'll talk about that in a second, but let's take a look at the example first, and then I'll talk about what the angle of elevation is and what the angle of depression is. All right, so it says it measures a 7.5 degree angle of depression to the summit of Mount Mitchell. There's Mount Mitchell right there. There's a nice little mountain. You don't have to draw it that pretty, but there's a mountain that goes up here. The bottom of the mountain, I guess they're assuming is at sea level, according to the picture. But here's the mountain. Now, the plane is flying higher than the mountain. Hopefully it's flying higher than the mountain. If it was flying lower than the highest point of the mountain, and if it kept on going, it would probably run into the mountain, all right? So it's flying above the mountain, and at an angle of depression, and that's a new thing today, of 7.5 degrees. I want to show you what the angle of depression is. Here's the plane. If it was to continue going straight, which it is, the plane is actually continuing going straight. But if you continue a horizontal line from the airplane, just going straight across like this, the angle of depression is the angle from the horizontal down to the point that you're looking at, all right? So they're looking at the top of the mountain. Can you get the door, please? Apparently he can't knock. All right, come on. So here's the angle of depression. It's from the horizontal down to the line of sight, okay? Your line of sight, they're in the plane, they're looking down at the top of the mountain, right? So if you're looking like this, the top of the mountain is down there because you're above the mountain, right? So your angle of depression is from the horizontal down, right? Depression, depressed, meaning goes down, right? So depression, you're going down to that mountain, okay? To the point of the mountain. You're not looking at sea level. They want to find out how tall it is from where you are to the top of the mountain, okay? That little X right there, that's what they're asking for, okay? So the angle of depression is from the horizontal, and that line of sight is down like this. Everybody see that? This is where you're in the plane, you're looking at the top of the mountain from here to here, okay? But your horizontal is right there. That's your angle of depression. Everybody with me on that? All right, we'll talk about the angle of elevation in a few minutes, but that's the angle of depression from the horizontal down to the line of sight. All right, that's about as simple as I can say it. All right, let's keep reading. It says angle 7.5 degree angle of depression to the summit, which means the top of Mount Mitchell. After flying another 2,400 feet, so here's where they measure the angle. Okay, they're 2,400 feet away from the mountain. Everybody with me? So they measure it, and they have devices nowadays. It's all like computerized and GPS and all that kind of stuff. But back in the day, they would have a device, like on ships and stuff. I don't know if on airplanes they called it this, but they call it a sextant, sextant. What it does, it measures from a horizontal, and you move it. Here's the horizontal. You hold it like this, and then you measure it until you see the line of sight, and it tells you the degrees. Okay, there's degree measures in there. It's like a physical thing you have in your hand. People on ships and things like that used to use those all the time. But again, now with electronics and GPS and satellites, it's different, but that's what they used to do. All right, so that would be the angle of depression. And what you're trying to do, it says, if they are, after flying 2,400 feet, they are directly above the summit. And you want to find out how high is that mountain. All right, so that's crazy stuff. Now, they do know how high they are above sea level. All right, but when they go 2,400 feet, apparently they don't know how high they are above that mountain, so you have to use trig to figure it out. And so we use a right triangle. Here's the horizontal. Everybody see that? And here's the vertical. You're directly above it now. This plane has flown 2,400 feet. Now it's directly above it. And here's your line of sight that we had before, so you can make a nice right triangle out of it. And what we're going to do is we're going to figure out how high the mountain is. But before we find the actual height of the mountain, because that mountain is not really part of our triangle, is it? You see it? It's not. Okay, it's from where the plane is to the top of the mountain. That's the height that we can find with our trig. And then what would you do to find the height of the mountain? That's right, because remember, how high are you above sea level? You're 7,000 feet, okay? So if you could find that little bit right there, that little X right there, then you should be able to find the rest of that mountain, okay? Now, they've done it for you right here, but let's just take a look. Guess I could use my marker thing. So you're right here. What angle do you have? I'll tell you what. Let me change my little pen stuff here. I'll make it in red so we can see a little bit. All right, look at this angle right here. See that angle? That's the 7.5 degrees. That's the angle we're using. Now, according to our trig ratios, what is the x and what is the 2,400? The x is what to this angle? Is it opposite? Is it hypotenuse? Is it adjacent? Which one is it? What is this one? It's opposite. Very good. So it's opposite this angle. What is the 2,400? It's adjacent. So you've got opposite and you have adjacent. So which trig function are you going to use? What's the word you've gone the whole weekend now. So what is it? Long weekend. It's what? SOHCAHTOA, right? Okay, and which one is this? This is the O and the A, and that's the TA, so it's the tangent. That's why they use tangent right here. Everybody with me? Okay, so they use the tangent of the angle. Always take the tangent of the angle. I'm going to say this a lot because a lot of students mistakenly take the tangent of some other number. You can only take the sine, cosine, and tangent of an angle. All right, so you look to see what angle you have, the 7.5. You take the tangent of that angle, and that's the opposite over the adjacent. See what they did? They put the opposite, which is x, over the adjacent, which is the 2400. And now you do some math. They kind of showed your steps right here. They kind of did. So how did they get that 2400 next to that tangent of 7.5? What did they do with that 2400?
They will.
Yeah, you multiplied it because, look, you're trying to get x by itself, correct? And you got to get rid of that 2400. What is that 2400 doing to the x? It's dividing it. How do I get rid of something that's being divided? You multiply it. Okay, so you multiply that by 2400, and then you multiply that by 2400. Everybody see that? Very basic algebra. You've done that a million times. So that cancels. I'm left with x. Now what they did is they just put x on the left-hand side just to make it look a little prettier. Everybody see that? All right, so x is what? 2400 times the tangent of 7.5. Now, how in the world did they get that number right there?
The tangent is 7.5 times.
But what did they use? They used a what? Use calculator. That's right. Use calculator, okay? I'm not going to show you how to do that on the calculator. We've done that already. But make sure that you can do it on your calculator, because when you have a quiz on this, which you're going to have on when? When's the quiz? On Thursday. You're going to need to know how to use your calculator. Do not come in here expecting to borrow my calculator or borrowing somebody else's calculator. You need... Sorry, you weren't the only one, I guess. So anyway, you need to come in here and you need to have your calculator, all right? And you need to know how to use your calculator. So you should be doing your homework with your own calculator. You know how to use it. Because certain calculators do things differently. So make sure you know how to do it. Put in a calculator, you get 316 feet. Is that my answer, 316 feet? Is that how tall that mountain is, 316 feet? No. Okay, that's just this little part right here. Okay, so that's the opposite. Okay, we'll put 316. What you're trying to find is this. You're trying to find from there to there. All right? So how do I find that? Well, I knew the whole thing was 7,000. If this little bit right there is 316, how do I find the rest of it? Just subtract, and it's right there. Okay? So they use A for altitude, probably the altitude of the, and it doesn't matter what letter you use. All right, but they used A for this red line right there. So they took 316 away from 7,000. They got to 6684, and that's how you do it. So what was the real new thing about this? The angle of depression. Okay, the angle of depression. Now they drew it for you. Okay, so that was nice of them. It was an example, so they probably would. But I could actually put this. I could put that right there on the test or the quiz and not give you a picture. So what you need to do is you need to be able to draw the picture. It doesn't have to be as pretty of a plane as they draw right there. You don't have to draw, you don't have to draw a plane. Just put a dot or an X or something like that just to represent where the plane is. But you will need to draw something that represents a mountain. At least you know the mountain doesn't go all the way up to the top of the plane, because if it did, the plane would crash into the mountain. All right. So if it went 2,400 feet, it's below the plane. So this is the kind of stuff that you're going to have to draw. Have you ever? Well, you're in 9th grade physical science, right? Did you do it? Oh, you did it last year. Okay. So last year you probably did physics and chemistry. You remember that word, physics? Okay. Is everybody listening? Okay. So this is very, very similar to a physics problem. Okay. It's real super basic. It doesn't really get into a lot of physics, but it's basically what physics is. It's taking words, right? Knowing formulas and equations, taking words and a sentence like this, or a couple sentences, and be able to transfer it into a picture, right? And then from that picture, transfer it into the math that we're doing, and then come up with an answer. This basically is what physics is all about. So if you can do stuff like this, and if you feel comfortable with stuff like this, physics shouldn't be a problem, all right? So don't think of it as being something like real scary, all right? Because it's not exactly physics, but it's kind of like doing physics, all right? Let's see. I had another example here. This one. Let's copy that one. Let's move this over to here. Let's put this right there. There we go. All right, here's another example. Now this time, you know what? Before I do that example, because they don't use angle of elevation, let me just do something really quick here. I'll just slide it right in between these two. So let's talk about this. If I had a horizontal line, okay, let's do this. Let's put two horizontal lines. Okay, and let's change color of this. Okay, and let's say you had an object down here, all right? And let's say you're up on top of a cliff or something, or a building, or you're up high, all right? In an airplane, whatever. And you're up here. And what you're trying to do is you are looking from up here and you're looking down here, all right? So let's do the line of sight, okay? So from here to there. You with me? All right, this is a building. This is it's perpendicular to the ground. So that means that would be a right angle right there, okay? So we have two elevations here. We have this one right here that we just talked about. What would we call this? The angle of what? Depression. Now, we don't say depression because we get all sad and stuff, okay? Depress means to do what? To go down, okay? Down, okay? Because when you're depressed, you feel down and out, you know, that kind of thing. That's why they use the word depression. But this is down. So watch. This is your angle of depression. Now, I want you to see something else. What was the title of this lesson? It was angle of blank and depression. What was it?
Elevation.
Elevation and depression. Let's talk about the elevation. Now watch. Let's say you were down here and you were looking up here. Everybody see that? So remember what the angle of depression was. It was from the horizontal down to the line of sight. Well, the angle of elevation is kind of the same thing. But this time you're down below and you're looking up, all right? So here's your horizontal right here, all right? So you're here and the angle of what? Elevation is right there. So this is the angle of elevation, right? Everybody see that? Now, in this situation, tell me something about the angle of depression and the angle of elevation. There's a relationship. It's adjacent?
No, the angle of depression is adjacent to the angle of elevation.
Say it. Why are they equal to each other? You're right. You're absolutely right. They are equal to each other. Because they're the same thing? Okay, they're equal because they're the same thing. But geometry, Kiki, tell me. You got two parallel lines. If this is horizontal and this is horizontal, they're parallel lines cut by a transversal. Okay, you're on the right track. Still haven't heard it yet. What are these two angles then? If this is two lines cut by or two parallel lines cut by a transversal, they're not vertical. It's not opposite interior. What word did we use? We didn't use opposite interior. We used a special word. It starts with an A.
Adjacent.
It's been that long. We did a lot of this. We did a lot of this. A,
Give me a hand with second letter.
L,
Altitude.
T. It's not
Alternate.
alternate. It's alternate interior angles. We did that a ton. I know it's been a while, but we did a ton of those, okay? So these right here are alternate interior angles. Would you agree? Yeah. They're alternate interior angles. Here's my parallel lines. Here's my transversal. The alternate interior angles, so they're equal to each other. So if this was angle theta, what would this down here be? Angle theta, because they're exactly the same thing, okay? So the angle of elevation is equal to the angle of depression. So that's pretty important. I thought in the second example they would do an elevation problem. They don't really, but that's okay. You might have some problems on homework that give you angle of elevation and angle of depression. All right, let's go to this. With that said, I should have probably done that right off the bat, but that's okay. It doesn't matter. This is it's kind of the same. It's similar, but not exactly. Let's take a look. They drew a picture for you, which is nice. Because if you just read these words, it might be a little difficult to actually draw the picture. So they draw the picture. This is an example, so they're going to help you out a little bit on this, okay? So let's take a look at it. A surveyor. You ever see these guys on the side of the road, and they got these big tripods? They got this thing, almost looks like a camera, on this big tripod, big long sticks. And then you got another guy, like way back, holding up a pole like this. Has anybody ever noticed that?
No.
You've probably seen it. You probably just never thought about it when you saw them out there. But they're surveyors. What they're doing is they're trying to measure out and get the right angles for the land and all that kind of stuff. Okay, so property lines and things like that. Especially if like some company is building like a big warehouse or a new building or something like that, you'll see these guys out there. Nowadays, again, it's all electronic. It's GPS and all that kind of stuff. But they used to use trig to be able to do this. And I actually worked at DelDOT. You know what DelDOT is? Department of Transportation. And my job, I don't think I ever told you this, my job all through college, this is how I paid for a lot of my college, is I fixed signs, all right? Signs that got knocked down. Stop signs, yield signs, street signs, all kinds of different signs. What do we call those? Anyway. That's what I did. Okay, we'd go down. They would tell us, people call in all the time to DelDOT, say, hey, we got a sign down here. So in the morning, we'd go, they'd give us slips of paper and they say, okay, go to this place, go to this place, go to this place. And we took all day to find all these signs and we'd fix them and put them back up. So there were guys that worked. I didn't work directly with them, but they did work around us every once in a while, and they were surveyors. All right, and I thought, oh, that'd be a cool job, because you can actually use your brain a little bit. Doing the sign thing, it wasn't brainless work, but it was just kind of monotonous. But I thought, oh, it'd be so cool to be those guys and hold up the stick and look through the thing and do the math and all that kind of stuff. And they would actually do the math. They'd have a calculator and stuff, and they would draw things out, and they would do exactly this kind of stuff. Not exactly this, but stuff very similar to this, all right? So there's jobs out there that they do this. And again, like I said earlier, nowadays they have computers and and all kinds of different things. They probably have apps. Who knows? I don't even know how they do it today. But this is the kind of stuff. So a surveyor, they must find the distance between two posts, A and B. All right. The problem is A is over here on one side of the river, and B is over here on the other side of the river. And what they have to do is figure out that distance from A to B. Now, what they're not going to do is they're not going to swim across the river and have a guy over there with a tape measure and then, one guy hold the tape measure and one guy swim across with it and then figure out the distance. I mean, that's a possibility. I guess you could do that depending on the river, how wide it is and all that kind of stuff, how long your tape measure is, or you could take a piece of string or a rope or something. I guess that's one way to do it. But let's just say it's a raging, roaring river and you can't get across. All right. So what you got to do is figure out that distance from A to B. Now, remember, these guys have a device to figure out the angle. All right. So they figure out the angle right here. So they're standing here. They're standing here and they got to figure out that distance from here to here. All right. And they have this little device that they can figure out the angle. So if you go like parallel to the river right here, you could actually measure that pretty easy. How could you measure that? You could step it out. You could have a tape measure. You could have a rope. You could have a string, whatever. They even have these little wheelie things, right? With this big wheel, and you run it along the ground, and it actually tells how long it is. So like when they do the football fields and things like that, they don't have a tape measure. Okay, it's way too long to have a tape measure. So they have this little, this little roly-poly, I guess. I don't know what they call it. But they would roll it, and it clicks the distance, right? How many feet, how many yards, whatever it is, okay? In this case, meters. So they probably had something like that, and they went from this point to this point. So where did they pick C? Is it just any random point? No, they made it. I'm going to be moving people in the room pretty soon, okay? And then after that, pretty quickly, then you'll be moving out of the room. So I'd really appreciate especially in that back corner. That's where all the problems going on. But you pay attention. Shh. Don't need it. So what you're going to do is you're going to go directly across from B to make a right angle right here. So you go directly across. Somebody puts a marker there. Somebody stands there, whatever. And then from this post, I don't know why they have to measure from A to B, but they do. Right? Maybe they're putting some kind of wire across. I have no idea what it is. Maybe a bridge that's going across like this instead of going across like, I don't know. But that's what they want to do. So let's read the problem. Surveyor must find the distance between two posts, A and B, on opposite sides of the river. After placing a post directly across the river from B at C, directly across, meaning it's perpendicular to this line right here. Okay, it's perpendicular to the river, really. Okay. It says she walks downstream along the bank right here, walks downstream 180 meters, perpendicular to the line formed by B and C. You could see, if all you had was the words, this might be a little bit hard to figure out. But once you see the picture, it's not that hard, okay? And measures AC, this length right there, measures it to be 180 meters. That's not a difficult thing to measure. It would be very difficult to measure from A to B. But from A to C, it's pretty easy to measure. Yes?
Why don't you do
Because I don't know the length of this BC, and I don't know the length of BA.
Is it BC the same as CA?
No, we never said that. We said it's perpendicular. It might look like it, but it doesn't mean it is. Well, it's a right triangle, but it never said on here that BC and AC were exactly the same. All right, so we can't make that assumption, even though it might look like it on here, okay? Because anyway, we know it's not, because if this is, what would this side, if these sides were equal, if this BC was 180, what would this angle right here have to be? It would have to be a 45-degree angle.
How do you know that?
Because when you have two angles in a right triangle, and they're the same, that means the two sides that are opposite must be the same. All right? So it's stuff that we've talked about before. It's not new. All right, anyway, we got all this set up. You probably figured it out already. They got it on here. So what trig function are we going to use? Now you see which one they're going to use, but what are we trying to find? We're trying to find this right here. We'll call it, they call it C, so let's call it C. All right? Since that's angle C, this is side C. So if we're going to use this angle, and we know this side, and we're trying to find this side, what are they? This one is what to this 43 degrees? Adjacent. What is the C? It's hypotenuse. So this is adjacent, okay, and this is hypotenuse. So what trig function uses adjacent and hypotenuse? So CA, C-A-H, right? TOA. So CAH, that's cosine equals adjacent over hypotenuse. Everybody with me? So there it is. The cosine of the angle, cosine of 43, equals the adjacent is the 180, over the hypotenuse, and the hypotenuse is the C. Now, the math on this is a little trickier than what we did on the last one. The last one step. We just had to multiply by something, and we got it. On this one's a little different. We've done this, though, before. So how did they get this? Well, what they do is they multiply both sides by C, and you multiply that by C. Well, that C and that C cancels. You see how that's where they got it? All right, so it's C times the cosine of 43 equals 180. And then what did they do? How did they get C by itself? That's right, they divided by the cosine of 43. Now, they didn't show it on the left side. Oops, that's pretty ugly. Let's try to make this a little bit better. They didn't show it on the left side, but they did it on both sides, okay? So they divided by the cosine of 43 on both sides, and that's what you got, right? We're not going to leave our answer like this, okay? It's a practical problem, so we don't want to leave it like this. Stick it in a calculator. And again, if you look at this, see it's like a little squiggly equal sign. Right, it's approximately equal to, and we're good enough with approximate at this situation. And there you go. So it's approximately 246 meters. So that's quite a bit different. Okay, 246 meters. This was 180, and this is 246. Only a 2-degree difference. Everybody see this? Okay, because we thought at first they might be equal to each other. But just a 2-degree difference goes from 180 to 246. That's a big, big difference, isn't it? all right, according to how many meters you have, all right? So that's the kind of stuff that you're going to be doing, okay? You can call them word problems, you can call them story problems, whatever you want to call them. They're practical problems. It's a practical use for what we're learning in here. Ben? No, I would do this. It depends what kind of calculator you have, but it seems like a lot of you guys have a calculator similar to this. It may not be a graphing calculator, but I got to change it to degrees. Yours probably stays degrees, but mine, since it's an online calculator thing, it just, every time I shut it off, it reverts back to radians. We're not even going to do radians this year. In Algebra 2, possibly you'll talk about radians. Definitely when you get into pre-calculus, which is only 2 years from now for you, they'll definitely talk about what radians are and that kind of thing. But we're not going to talk about that here in geometry. So here's how I would do this. I would go 180. Now, if you're watching this on YouTube, you won't be able to see it because I did not this weekend. I said I was going to go through and try to figure it out. So what I'm going to do, I'm going to put this in parentheses. I don't think you have to, but I'm just going to be safe and put it in parentheses. So 180 divided by the cosine of 43. And I really don't think you have to do it, but I like to do it. So the cosine of 43, you could just stop it right there, but there's the one parentheses for the 43. There's the other parentheses for the cosine. Again, I don't think you have to put any of those parentheses in there, but you hit enter, and then there's your 246, okay? And again, it's approximately 246 because it's 246.118943, blah, blah, blah. It keeps on going, all right? But we can just round it to the nearest meter. Doesn't tell you how to round it, but on something that big, 246 is perfectly fine, okay? So that's how you do it on a calculator like this. Now, some of you guys have a calculator where you don't put cosine first, you put 43 first, all right? So you'd still go 180 divided by, and then I'd hit 43 cosine, all right? And then what you're going to see on the screen is what the cosine of 43 is. Then you hit equals, and then it should give you the 246. You need to know how your calculator works. Everybody hear me on this? I said that at the beginning of class. I can't stress that enough. You have to know how your calculator works. So make sure that you practice this, okay? Even on this example, get the calculator out, put that stuff in your calculator, make sure you get the answers you're supposed to be getting, all right? Because I don't want you to do everything right. I don't want you to set the thing up right and then mess up on your calculator. Just because you have a calculator doesn't mean you're going to get the right answer. You got to put it in correctly. And sometimes when you get this trig stuff, sometimes putting it in correctly is not as easy as people think. All right, that's good enough. Well, you have the you got the lesson plan in front of you, 1 through 15. Okay, so I'll just put it on here. So it's section 12-2, and it's 1 to 15. Call this A. I think I wrote that correctly on the lesson plans, didn't I? Did I put A?
What'd you say?
Nobody's talking to me. Yeah, 12-2A, and you're doing 1 to 15.
Wait, what were you missing on the day with that?